Today we are discussing the linear pattern. So when is a number pattern linear? A number pattern is linear when there is a constant difference between the terms. Okay, let's have a look at example 1. 11 minus 7 is 4. 7 minus 3 is 4. So we're going to say that the constant difference is 4. So the difference between every second term, every two terms would be 4. And we're going to abbreviate it as D, which is 4. Okay, so now we can write T1 as 3, T2 as 3 times 1, 4, T3 as 3 plus 2 4s. And if we want to expand this number pattern, then we can say T4 is 3 plus 3 4s. T5 is 3 plus 4 4s. T6 is 3 plus 5 4s. Okay, so look at these numbers here. T6 is 5 4s. T5 is 4 4s. T4 is 3 4s. T2 is 1. T3 is 2. Okay, so we see something interesting. If we therefore want an unknown term, something like T number n, what will we write? We will say 3 plus n minus 1, because it was always 1 less than the n, times 4. Okay, let's simplify this. 3 plus, let's multiply the 4n, and there we go, we have 4n minus 1. That is our general term for this sequence. With this term, Tn, the general term, we can work out any number in this pattern. Okay, so let's look at question example 2. What is negative 5 minus 6? It's negative. Negative 5 minus 1 is negative 6. What is 1 minus 7? It's also negative 6. So in this case, D, the common difference, is negative 6. Let's try and write it in the same format as the previous one. When we expand this sequence, we say T1 is 7, T2 is 7 plus 1 minus 6. T3 is 7 plus 2 negative 6s. T4 would be 7 plus 3 negative 6s. T5 would be 7 plus 4 negative 6s. So therefore, Tn would be 7 plus n minus 1 negative 6s, which gives you 7 minus 6n plus 6, which is 13 minus 6n. I know what you're going to tell me now. You're going to say, why must we do such a lot of PT to get this Tn? We learned a much easier way in grade 7, 8, and 9. Yes, that is true, but we are working towards a general formula for Tn. Okay, so this is an interesting example. It hasn't got real numbers, it's just got letters or variables. And in this case, T1 is A, T2 is A plus D, and T3 is A plus 2D. So now my question is, what would Tn be? Well, if you look at this, you can see that Tn would be A plus, and then one number less than the term number. So that would be n minus 1, because there's an n. Now we have an n minus 1 times D. Okay, so that is what we call the general term for any linear pattern. Okay, now A will be the first term, and n will be the number of terms, the number of the term, and G would be the constant difference. constant difference, and Tn would be the term on place n in the sequence. Okay, so let's do a little example to explain this. Let's take the sequence 1, 4, 7. A is going to be 1. D is, of course, going to be 3, the constant difference. And the general term of this sequence would be Tn equals 1 plus n minus 1 times 3, which is the D. And if we simplify that, we get this, which simplifies to 3n minus 2. So how do you get any term in this sequence right here? That is our sequence we're working with. How do you get T20? Well, it's 3 times 20 minus 2, which is 60 minus 2, which is 58. Okay. In example 4, the general term Tn equals minus 2n plus 5 is given. The questions they ask here are the typical questions that are always asked in a number pattern question. First question is determine the 10th term. Okay, in this case, n is 10. So T10 would be minus 2 times 10 plus 5, which gives you minus 15. So the 10th term is negative 15. The second one, they give you the term minus 99. So that's Tn. So we're going to make that minus 99. And then we're going to use the rest of the formula and work out n. So if we subtract 5 there, we get 104. And then if you divide by 2, you get 52, negative 52. So negative 99, positive 52, is the 52nd term. Okay, and the third question, how do you get the first 3 terms? Well, you need T1, T2, and T3. And to get that, you would sub in a 1 in n's place there. So it is negative 2 times 1 plus 5, which gives you 3. Then you sub in a 2, which gives you 1. Then you sub in a 3, which gives you negative 1. And there's your first 3 terms. This is a descending pattern. Okay. In this final example, we're going to look at the method you used in grade 7 to 9, as well as the new method to get a general term Tn. So let's work out the difference. In the first place, the difference here is negative 10, and negative 13 minus negative 3 also gives you negative 10. So D is negative 10, the common constant difference. So in the previous grades, you have said that Tn would be D times n plus T0. Okay, how did that work? You just took the minus 10, you times it with n. So how would you get term 0? If that is term 1, the minus 3, then term 0 is just the term before it. So term 0 would be term 1 minus negative 10. So that's negative 3 plus 10, and that gives you 7. So we would put plus 7 there. Okay, so there would be your Tn as worked out in grade 9. You can still use that method, that is fine. But it's necessary to be able to do the other method too, which is Tn equals A plus n minus 1d. What is the A value? It's the first one, it's negative 3. The n minus 1 stays, n minus 1, and your d value is now negative. So you must remember to put little brackets around that. That's very important. And then your answer would be negative 3 minus 10n plus 10, which also gives me exactly the same answer as the other one. Negative 3 plus 10 is plus 7. Okay, So both of them give you exactly the same answer. This answer and this answer is the same. It's just method A, and this is just method B. You can choose which one you want to use, as long as you remember how this one, method B, works for grade 12. That's enough on linear patterns. Goodbye.